Alright, so let's start creating some artificial intelligence for our game. We're going to start out a little simple with just an AI which head follows you. So we're going to be messing with the bones of our mannequin. And this is a really fun trick because it's useful to put on pretty much any AI that you need to be looking at you. So let's get right into it. Let's make a new folder called AI. And I'm going to make a subfolder just called head follow AI because we're just going to be making this its own thing for now. So we need a new character. So let's right click, blueprint class, character. And we'll just call this head follow, or let's make it a AI head follow. There we go. And we can open it up, and we're going to add our mannequin as the mesh. So mesh inherited right here. Just choose the SK mannequin. We're going to position him correctly by giving him a -90 on the Z-axis, and then rotating him 90 degrees, or sorry, -90 degrees on the Z-axis as well. Now he needs an animation blueprint, so he knows how to animate. And we can set it right here, but we're going to make our own. So let's just right click, go to animation, and then animation blueprint. Then we can choose the UE4 mannequin skeleton, because this is what this is the skeleton we need to map it to, and we'll just call it ABP head follow. So it's going to be really simple at first. We're just going to take the idle animation on the lower right here under Asset Browser, and we're going to plug it into the result. Once we compile, it'll always play the idle animation no matter what. We can add them into the world just by dragging our character out, and we need to assign the animation blueprint. So go into the character, click on mesh, and then anim class. We just want to choose ABP head follow. So now he's in the world, and he will just stand there in an idle state forever. Alright, so let's go back into the blueprint, and let's mess with this setting so that his head follows you. We want to get what's called a transform modify node, and right here we can mess with the transform of a bone. So we need to select a bone to modify. So if we select the node, and then up here at the top we have the bone to modify, and we want to modify the neck. Specifically, if we can find it, the neck 01, because that's what we want rotating towards our player. Now we don't need to change the translation or the scale. So on here we have translation, rotation, scale right here. And we can just uncheck the exposed on translation and scale since we only need to mess with rotation. And we don't need this alpha as well, which is the strength. We're always going to have it at 1, so we can also uncheck the alpha if you'd like. So now it's just rotation and component pose. We can also plug this in. It's going to create a local to component node in between, and it'll do the opposite when we plug it into a result. So we should now be able to modify our neck bone. We're getting a warning right here because it says no components to modify selected, and that's because rotation mode is set to ignore right here, so we'll fix that now. And what we want is add to existing, which takes the current rotation and adds our input on top of it. If we select replace existing, our input would be the exact rotation it wants. Now if we compile, the error should go away, and if we can actually show you right now, if we just mess with the values and we look at our character here, his next now changes. Now I think we're killing him here, so let's reset this back to 0. Oh, well, now he's definitely dead. Let's promote this to a variable. So right click on the rotation, promote to variable, and we will call this head rotation. Oh, spelled that wrong. So let's go to the event graph and update this in the update animation node, which usually comes by default. And we are going to use, once again, this handy little node called find look at rotation, which will do all the math for us to get 2 points and find the angle between them. So for the start, where the AI is, we can just get this try get pawn owner node, pull off and get actor location, and put that into the start. For the target, we can get player character, get actor, not location, or not rotation, we do want location, sorry about that, and put that into the target. And we just want this return value to be set to the head rotation. And let's test out what that looks like right now. So if we hit play, our character's head follows us no matter where we go. It's always looking at us. So right out of the box, that works pretty well. Of course, it can do this, which is quite unnatural. But if you want your character to do that, then it's perfectly fine. We did get one error, access none, trying to read property, get player character. So let's figure out what's causing that problem. But before we do, I forgot to demonstrate one thing. If we crouch or jump, you can see he rotates his head on the wrong axis. Not the one he's supposed to be doing. So we're actually going to fix that first. I believe the reason we are getting the error is because the update animation manages to fire one off before it realizes who the player character is. So we just want to make sure the player character is valid. So get player character, go get is valid. We want to get the macro right here. And we only want to continue if the player is valid. So let's see if that fixes our first issue. So we just load into the world, we leave, and we get no more error. Perfect. Next we'll work on the his head rotating correctly when we move vertically. So to fix that, we will get this find look at rotation, and we're going to break it. Break rotator, and we will make a rotator from the head rotation. Make rotator. The Z will go into the Z. And before I continue, if you are having an issue where the head is offset by 90 degrees, which I've seen happen before, I'm not quite positive when it does happen and when it doesn't. It just seems to happen sometimes. Right here, you can add a float plus float, and then add -90 or +90, whatever you want. I'll show you right now. With that added, you can see it still follows us, but it's offset by 90. This might happen to some people by default, so just add this node in to correct it. But for us, it is already working, so we're just going to go Z to Z. But since the X and the Y are switched, we need to get the Y and put it into the X, and then the X and put it into the Y. So now, if we hit play, and we go and we jump, you can see he looks down when we jump, and he looks up when we crouch. So we almost have it perfectly, it's just inverted. So we will just take this Y value, and we need to multiply it, float times float, by -1, and put that value into the X. And that should invert it for us. We hit play, we hit jump, and he looks up at us, and we crouch, he looks down at us. So now his head perfectly follows us no matter where we are. So this looks really great and really creepy, but what if we don't want his head to turn past a human limit? I don't think this here should be possible, so let's add some limits. And we'll do this by adding clamps. So if we go into our blueprint and we have this Z to Z, what we're going to do is add a clamp angle. So clamp angle right here, and put the return value into the Z. If you had to add the plus 90 or minus 90, do this after the plus 90 or minus 90. So it would look something like that. And for the min angle degrees, I'm going to make it -45 and the max angle 45. So we can test it again. Now if we hit play, and he looks at us, and once we go past 45 degrees, he won't turn his head anymore until we get to the other side, which will look 45 degrees this way. So it looks good, but lastly, we want him to go back to looking forward if he goes past his limit, and we want him to smoothly move his head towards normal instead of snapping there, because if you'll notice, when we go to the other side, his head will just snap to the right or the left, and we want him to actually turn his head over time. So we just need to add a new boolean in the blueprint, and it will be called can_see_player. So after we set the head rotation, we just need an if statement right here, and we just need to make sure his head can turn far enough. So we will get this z value right here, and we just need to check if his head is able to rotate and look at us. So we will get the head rotation and split it, and we can get the z. And we're just going to ask if it is greater than -45 or less than 45. So we'll add an OR node. Oh, I'm sorry, I did this backwards. So if it is greater than 45 or less than -45, then we cannot see the player. So if that is true, can_see_player is set to false. So if it's outside these values. If it is false though, we can see the player because it's inside those values. So before we set the head rotation, we only want to update it to this find look at rotation if we can see the player. So off of is valid, in between the is valid and the set head rotation, we just want to make sure we can see the player. And if we can, we will continue normally. If it's false, we want to set the head rotation to 0 on all axes. And then we want to make sure to plug this into this if statement so it can continue to update whether we can see the player or not. So we can test that now. And if we hit play, if we go out of his view, he should snap back to 0. And he doesn't seem to. So let me figure out why. Okay, so I see the problem. We're not supposed to use the actual head rotation since this won't ever go above or below these values since we clamp it. So instead of the head rotation variable, we need to take it from the z of the find look at rotation. So let's move these over a bit, and then if I control grab these two, I can move them to a different node, and I'll move it to the z of the break rotator of the find look at rotation. And then we can just delete this variable right here. Now if we compile and play, it should work. As you can see, once we leave the 45-degree limit, his head just snaps back to 0. But we want him to do this over time, so we need to make it interpolate. What we should also probably do is make these into variables. So I'm just gonna right click, do max head turn and min head turn, and then just plug the min head turn or max head turn into here and min head turn into here. So to make it more natural, for him to interpolate it back to 0 instead of just setting it back to 0, instead of a set head rotation, we need to use an r_interp2. So off false, I'm gonna just search for r_interp. So I'm just going to right click and search for rinterp2 and get this node right here and plug the return value into the head rotation. So the current is whatever our head rotation currently is, and our target we don't have to change because our target is 0, 0, 0. Delta time, we can just grab from the delta time X here in event blueprint update animation. And the interp speed is how fast we want him to turn his head back to normal. I'm just going to make the speed 5 as a default, and we can test it out once again. Let's hit play, and if we go into his vision, he snaps his head towards us, we move out, and he moves his head back over time instead of snapping. But he still snaps his head when we come into it. Okay, so let's go back into our blueprint, and here we set our head rotation to this math here from the find lookout rotation, and we're going to need another rinterp2 node. So the current will be our current head rotation. Our target is going to be this find lookout rotation math that we did. Delta time will be the delta time from the blueprint update animation. And the speed is actually going to come from a select node. We can't be constantly using an rinterp2 node if it's always trying to set our new lookout rotation, because there will always be a constant delay. So we only need to interpolate it if we're going from a head rotation of 0 when we can't see the player to seeing the player. If it's going from seeing the player to seeing the player to seeing the player every single frame and interpolating every single frame, it's going to have a constant delay, and that's going to look really bad. So the interp speed will come from a select node. And for the index, we're going to use a new Boolean called interp towards player. Plug that in. If it's true, then we want to set our interp speed to 5, which is the same I set for the other one. And if it's false, we'll set it to 0. So it's still technically using the rinterp2 node, but the speed is set to 0, so it'll do it instantaneously instead of actually interpolating over time, so it'll look normal. So after we set the can see player to false up here, we want to set our interp towards player to true, so that we know to interpolate next time we do see him instead of just snapping with this select node. After we set the can see player to true again, we're going to add a delay of 1 second, and then set the interp towards player back to false. We need the 1 second delay so that it can finish its interpolation before setting this interpolation back to false. So we don't want it to start doing the interpolation, have it turn to false, and snap. So we need to wait just a second. So let's test that out now. So when we go into view, he interpolates his head towards us, and we come out of view, he looks away. And when we're going, when we're staying in view but moving his value, the interp speed is set to 0, so there's no delay, which works perfectly. Alright, so now he very naturally moves his head to always be looking at us within its limits. And it looks really great. This is something that you can use on any one of your AI, since head following is very common within AI. So that'll be it for this episode, and I will see you in the next one.